All right, so this is continuing off problem number 17 from the first part of the review. So I'm going to finish this up and start with the second part. So here it says find the minimum value and the maximum value of the objective function when c equals 4x plus 5y, subject to the following constraints. So we have our constraints here that we're going to graph, and then we're going to use our vertices from the feasible region to check which one is going to be our minimum value and our maximum value. So for the first one, x is greater than or equal to 0. That's going to be a solid vertical line. And since it's greater than or equal to, we shade to the right. So I'm just going to put some lines here showing that I'm shading to the right. For the next one, it says y is greater than or equal to 0. So that is a horizontal solid line. And greater than or equal to, you shade above that line. For the next one, it says x plus 2y is less than or equal to 16. So I'm going to subtract the x first. Then I'm going to divide everything by 2. So y is less than or equal to negative 1/2 x plus 8. So my y-intercept is at 8. So 1, 2, 3, 4, 5, 6, 7, 8. And my slope tells me to go down 1 and to the right 2. And this will be another solid line. And it is less than or equal to, so we shade below. So we can see that our feasible region right now is looking inside of this triangle. And for the last one, it's pretty easy to solve. It's just going to be, let's do it in this color. You subtract it, it's y is less than or equal to negative 5x plus 35. So this one's a little bit tougher to graph. You start at 35 and you go down 5, right 1. So that's a little bit tough. So what I like to do is just find the x-intercept. So if you do the cover-up method, you see that 5x is equal to 35. You can divide by 5, and x is equal to 7. So 1, 2, 3, 4, 5, 6, 7. And the slope tells me to go down 5 and to the right 1, which I can't do. So I can go backwards. I can go up 5, 1, 2, 3, 4, 5, and left 1. Then up 5, 2, 3, 4, 5, left 1, 2, 3, 4, 5, left 1. Another solid line. And this time, again, we shade below, less than or equal to. So now we can see that our feasible region is right in this little trapezoid area. No, it's not a trapezoid, it's just a parallelogram. Or quadrilateral, sorry. So we're going to use our vertices. Our first vertex is going to be right here at 0, 0. My second vertex is going to be right here at 0, 8. My next one, I can use this at 7, 0. And the last one can be at 6, and then 1, 2, 3, 4, 5. So 6, 5. Then I'm going to plug these numbers into the objective function. So for the first one, 4 times 0 plus 5 times 0. So 0 plus 0 is 0. Then for the next one, 4 times 0 plus 5 times 8. So 0 plus 40 is 40. And then 4 times 7 plus 5 times 0 is 28. And then 4 times 6, which is 24, plus 5 times 5, which is 25. So 24 plus 25 is 49. So my minimum value is this one right here, which is 0. And my maximum value is here, which is 49. Okay, now we're on to the second part of the semester review. So for the second part here, it says, describe the transformations, sketch the graph, create a table based on the absolute value function. All right, so for here, first thing I'm going to do is talk about the parent function. So it's y equals the absolute value of x. So I'm going to use the values of negative 2, negative 1, 0, 1, and 2. So if I take the absolute value of negative 2, I come up with 2. Because remember, it's the distance that that number is from 0, so it's 2 units away. The absolute value of negative 1 is 1. 0 will not change. The absolute value of 1 is still 1, and the absolute value of 2 is 2. All right, so we're going to describe our transformations here. So for the first one, this is an a value. It is greater than 1, so I'll just put a greater than 1, so that's a vertical stretch by 2. This is h, it's the opposite of what you see, so it actually goes to the right 1 unit. And this is k, which is positive, so it goes up 3 units. Now I'm going to make a table. So the transformations that are affecting x is this right one, which is going to be x plus 1. And then what's affecting y is the vertical stretch by 2, so that's 2y, and then up 3 is plus 3. So when I go to my table for the x's, all I'm going to do is add 1. So negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. Now for my y values, I'm going to first multiply them by 2. So 2 times 2 is 4. And then I'm going to add 3. So 4 plus 3 is 7. 2 times 1 is 2. Plus 3 is 5. 2 times 0 is 0. 0 plus 3 is 3. 2 times 1 is 2. 2 plus 3 is 5. And the last one, 2 times 2 is 4. Plus 3 is 7. And here we can graph this. So at negative 1, 7. I think it's there. 0, 5, 1, 3, 5, 7. So there is my graph. We can see that the domain is left all real numbers, right all real numbers, so negative infinity to infinity. And the range is bottom, which is at 3, and goes towards infinity. Bracket on 3 because that is included. All right, for the next problem, same thing. Let's go ahead and look at the transformation. So this is a right here, which is less than 1 but bigger than 0, so that's a vertical compression by 1/2. This negative is like inside the absolute bar, so that's going to be a reflection across the x-axis. And this x plus 4 is in parentheses inside, so it's the opposite, so it's left 4. So once again, we're going to make our table and include our transformation. So the only things affecting x are the reflection across the, sorry, I put x-axis, I meant y-axis, sorry about that. So reflection across the y-axis is negative x, and left 4 is minus 4. For the next one, the vertical compression by 1/2 is half of the y values. So we take negative x, so negative 2, negative 2 is 2. 2 minus 4 is negative 2. So negative 1 becomes positive 1. 1 minus 4 is negative 3. 0 is 0, so minus 4 is negative 4. And hopefully you can see the pattern, negative 2, negative 3, negative 4, negative 5, and negative 6. And you can definitely verify that. Negative 2 minus 4 is negative 6. Then here for the y's, we take half of these. So half of 2 is 1. Half of 1 is 0.5 or 1/2. Half of 0 is 0. Half of 1 is 1/2. And half of 2 is 1. So my domain will not change. It will still be all real numbers. And the range, it didn't move or reflect, it didn't move up or down, and it didn't reflect across the x-axis, so it's probably just going to be 0 to infinity, a bracket on 0. So we're going to confirm this by graphing it. So negative 2, positive 1, negative 3.5, I'm going the wrong direction there, sorry, negative 3.5, negative 4, 0, negative 5.5, and negative 6, positive 1. So the graph looks like that. It's pretty flat. And you can see all real numbers for the domain and 0 to infinity for the range. For number 20, this is a reflection across the x-axis. And this is a right 2. So affecting x is right 2, so x plus 2. And affecting y is negative y. So for our table, we're going to add 2 to all the x values. So negative 2 plus 2 is 0. Negative 1 plus 2 is 1, 2, 3, 4. And we just take the opposite of every y value. So 2 becomes negative 2, negative 1, 0, negative 1, negative 2. I'll graph it so you can see the domain and range. So 0, negative 2, 1, negative 1, 2, 0, 3, negative 1, 3, negative 2. So the domain is all real numbers. And the range is going to be from negative infinity to 0 with a bracket on 0. All right, for these ones here, it's saying solve these, isolate the absolute value expression, so you can solve absolute value equations. Make sure C is positive. If it's not and it's negative, then it's going to be no real solution. All right, and I'm going to work these out on a separate piece of paper just because it does require a lot of work here. And if you're able to isolate it and equals a positive number, you're going to do the absolute value expression equals a positive c, whatever this number was, and then the absolute value expression equals negative c, so the opposite of what that was. Notice we do drop the absolute bars. So for number 21, we have 6 absolute value of 4x is equal to 18. So first thing we do to isolate the absolute bars is divide by 6. So the absolute value of 4x is equal to 3. Now this is isolated and this is a positive number, so we're going to do the absolute value expression without the absolute bars equal to positive. So 4x equals 3. And then we do the negative. 4x equals negative 3. For this one, we divide by 4. So x is equal to 3/4. This one we divide by 4. And x is equal to negative 3/4. Now, when it's set equal to a constant, these answers should work out. They should not be extraneous. But if you wanted to, you can take these answers, plug it back into the original, and when you work this out, it should equal 18 for both answers. Okay, let's take a look at 22 now. So for number 22, 2 absolute value of x minus 7 plus 3 equals negative 5. So the first thing we're going to do, we're going to isolate it by subtracting 3 from both sides. So 2 absolute value of x minus 7 equals negative 8. We're going to go ahead and divide both sides by 2 to isolate the absolute bars. Now we can see the absolute value expression is isolated, but the problem is it equals a negative c. So it is impossible to put any number here and get negative 4, so therefore the answer here is a no solution. Okay, let's go ahead and take a look at number 23 now. All right, so for this one here, first thing I'm going to do is add the 5 to the other side. So 4 absolute value of x minus 2 is equal to 12. We're going to divide both sides by 4. The absolute value of x minus 2 is going to equal to 3. Now it is isolated and this is positive, so we're going to write x minus 2 equals positive 3, x minus 2 equals negative 3. So for this one, we're just going to add 2 to both sides. X equals 5. Add 2 to both sides. X equals negative 1. And just because it's negative, don't assume it is not a solution. You can just type it in there. So let me go and show you real quick to show you how to check them. So you start with 4, absolute value. X is 5, so 5 minus 2. Arrow out, and there's a minus 5, and it should equal 7, which it does. And then we can do the same thing for the next one. So 4, and it's going to be negative 1 minus 2. Arrow out, minus 5, and that also equals 7. So both answers do check out, so just to verify. All right, let's take a look at number 25 now, or sorry, 24. So for 24, we have the absolute value of x minus 2 equals the absolute value of 4 plus x. Okay, so we look at this left one right here, and we see that it is isolated, and we're going to treat this as our c. So first off, we're going to drop the absolute bars, so that's going to be x minus 2 equals positive. So we just drop the absolute bars and don't change anything. To set it equal to the negative 1, you're going to do the same thing, x minus 2, but over here, when you drop the absolute bars, you're going to put a negative in front and then put parentheses so that now it's negative c. Because remember, this represents c, so this is 4 plus x, which is positive, and then negative 4 plus x, which is the negative c. All right, so as you work these through, first I'm going to subtract x to the left side, and hopefully you notice these cancel out, and you're left with a statement that says negative 2 equals 4, which is not possible, so this is an extraneous, it doesn't even exist. This part doesn't exist because that's not even a variable, okay? On the right side, we're going to work it out. First, we're going to distribute the negative sign. So let's put a negative 1, so that becomes negative 4, and this becomes negative x. So first, I like to move the variables to the left, so we're going to add x to both sides. So 2x minus 2 is equal to negative 4. We're going to add 2 to the other side. 2x is equal to negative 2. Then we're going to divide both sides by 2. And x equals to negative 1. you can definitely plug this in here. So -1 minus 2 is -3, but the absolute value of -3 is 3. And 4 minus 1 is 3, the absolute value is 3, so it does check out there. Okay, so if you're curious to check that out, or put in the calculator and work it out as well. All right, let's move on to the next ones. So let's go ahead and take a look at number 25. So 25 is going to be 3x minus 4. The absolute value of that is equal to x. So this is number 25. So notice it's already isolated, so we're going to do 3x minus 4 equals positive c, and then we're going to do 3x minus 4 equals negative c. So for this one here, I'm going to go ahead and add the 4 over. So 3x equals x plus 4. Now I need to map my variables to the same side, so I'm going to subtract x so they're on the same side. So 2x is equal to 4. Divide both sides by 2, and we isolate x and get x equals 2. 3 times 2 is 6. 6 minus 4 is 2. The absolute value of 2 is 2. If you plug in a 2 here, 2 equals 2. That answer checks out. For this one, same process. I'm going to add the 4 first. So 3x equals negative x plus 4. I'm going to add the x to the other side. 4x is equal to 4. We divide both sides by 4. And x equals 1. And once again, you can substitute it in there and you'll find out that the answer does work out. All right, we're down to the last problem from the front, which is going to be number 26. So the absolute value of 4x plus 5 equals 2x plus 4. All right, for this one, once again, it's isolated here. So we're going to write the positive c, so 4x plus 5 equals positive 2x plus 4. And the other one will be 4x plus 5 equals negative parentheses 2x plus 4. So positive c, negative c. All right, and we're going to work it out just like the other ones. We'll go ahead and subtract my variable over to the left side first. So 4x minus 2x is 2x plus 5 is equal to 4. And then we're going to subtract this 5 to the other side, which gives us 2x is equal to negative 1. Last, we can divide both sides by 2, and x is equal to negative 1/2. Here we're going to distribute 4x plus 5 equals negative 2x, negative 4. I'm going to add my variables to the other side, so I like to keep them on the left. So 4x plus 2x is 6x. Bring down your plus 5. This cancels, and it equals negative 4. We're going to go ahead and let me make sure I am doing this correct. 4x plus 5 equals 2x plus 4. Negative 2x, negative 4. So we're going to subtract this. And that gives me 6x is equal to negative 9. Divide both sides by 6. And x equals reduce negative 3/2. So this one I'll type in the calculator just to verify that they are correct. So let's see what we get here. So absolute value. So we have 4 parentheses, we have negative 1/2 plus 5. And we're going to see 2x plus 4, so 2 times negative 1/2 plus 4. And notice they're both 3, so this answer checks out. Now we're going to verify that negative 3/2 does work. So I'm just going to go up here, and we're going to change this 1 to a 3 to represent negative 3/2. Notice this one equals 1. And over here, the second equation, we change that negative 1/2 to negative 3/2. And we see that the answer is also 1. So that means that actually both answers, again, check out. So both solutions are real. All right, moving on to the next page. So obviously those answers are on a separate page. For here, it says solving absolute value inequalities. So for these ones here, you're going to isolate the absolute value. And if it's less than c and that c value is positive, you're going to use a between statement. And if you isolate the absolute value and it's greater than a positive c, then you're going to use a split statement. Now, one thing I want to point out is there's 2 special cases. Like if you isolate the absolute value and it is less than a negative number, that is no solution because that is not possible. If you isolate an absolute value expression and it is greater than a negative c, So greater than a negative number, that is all real numbers because that is always true. It will always be above a negative number. All right, so for here, I'm going to work out 27, 28, and 29 on a separate sheet of paper. So for number 27, we have 5, absolute value of x plus 8 minus 7 is greater than 13. So we're going to isolate the absolute bars. So first we will add 7 to both sides. So 5, absolute value of x plus 8 is greater than 20. We're going to keep isolating the absolute bars by dividing by 5. So the absolute value of x plus 8 is greater than 4. Now here it says greater than, and that's positive. So we go over here and we see greater than c. So we're going to use this. The absolute value expression is less than the negative number. So once again, this is c. So the absolute value without it is less than negative c, so that would be negative 4. Or the absolute value expression is greater than the positive c. So x plus 8 is greater than positive c, which is just 4. So to work this out, we're going to subtract 8 from both sides. So x is less than negative 12. Or the other one, we work it out, it's going to be pretty much the same workout. Subtract 8 from both sides, and x is greater than 4 minus 8 is negative 4. Okay, let's take a look at number 28 now. So we have the absolute value of negative 3x minus 2 plus 6 is less than 8. All right, for this one here, to isolate the absolute bars, we're going to first subtract 6. So the absolute value of negative 3x minus 2 is less than 2. All right, it's isolated. This is positive, so it is now less than, so it's this top one. So we're going to write it like this. So negative c, so 2 is going to be negative 2, is less than the expression is less than positive c, which is 2. And pretty much I'm just going to solve it in the middle. So first I'm going to add 2, and when we add 2, we add it to the middle, to the right number, and to the left number. So negative 2 plus 2 is 0. The negative 2 and positive 2 cancel out, leaving me with negative 3x. And then 2 plus 2 is 4. Last, to isolate this x being multiplied by negative 3, we divide every side and the middle by negative 3. So divide this by negative 3, the right side, and the left side. So 0 divided by negative 3 is 0. When you divide by a negative number, the sign must flip. Negative 3 over negative 3 reduces to a 1, so that's 1x. We flip the sign because we're dividing by this, and it's negative 4/3. And when you do flip the signs, it should make sense, right? 0 is greater than x, which is greater than negative 4/3, because 0 is greater than negative 4/3. All right, let's take a look at number 29 now. All right, for number 29, we have the absolute value of 9 minus 2x plus 10 is greater than or equal to 2. So for this one, first we're going to subtract 10 from both sides. So the absolute value of 9 minus 2x is greater than or equal to negative 8. This is isolated, but this is a negative number. So we look back at this, it's greater than. And it's greater than a negative. When it's greater than a negative, we said the answer was greater than a negative, all real numbers. So the answer to this one is going to be all real numbers. All right, so let's keep moving on. So for numbers 30 through 33, all we're going to do is we're going to, these are x values, all of these are x values, and we're going to see which restriction they fall between, okay? So like negative 1. Does this negative 1 fall between negative 7 and negative 1? Well, it appears it does, but this doesn't say equal to, so we can't say negative 1 is less than negative 1, so it does not fit here. But negative 1 does fall here because it says negative 1 is less than or equal to negative 1, which is less than or equal to 3. So negative 1 does fall here because of this equal bar. So what that means is we're going to plug it into this equation here. So 3 times negative 1 equals negative 3. For the next one, we have negative 5. And hopefully you see that negative 5 falls between negative 7 and negative 1. So therefore, we use this one here. So 3 parentheses negative 5 squared minus 2. My suggestion, double check your answer with a calculator, but negative 5 squared is 25. 25 times 3 is 75. 75 minus 2 is 73. 7 falls in the last one. It falls between 3 and 10, so 7 goes here. So the absolute value of 2 times 7 plus 1. So 2 times 7 is 14, plus 1 is 15. The absolute value of 15 is 15. Now take a look here, negative 10. Our graph starts at negative 7, so there's no way it can fall. Negative 10 can fall between any of these. So therefore, in terms of this piecewise function, this does not exist. It is not a part of the graph. Okay. So last but not least, we have these right here where it says to sketch the graph of the compound function, determine if the function is continuous or discontinuous, then give the domain and the range. Okay, so first off, for this first one here, I do make tables, as you know, so I'm going to make tables for 34. So for the first one, 5. I'm going to do xy, and this says x is less than 0, so our starting point is 0. Numbers less than 0 are -1, -2, -3, and so on. But usually these are x values. Let me go backtrack. There is no equal bar, so this is going to be an open circle when we graph it. So usually there's an x up here in the equation that we plug these x values into, but since we can't, what this graph tells us is that the y value is actually always going to be 5. Okay, so we're going to plot this point at 0, 5, and it's going to be an open circle. And then we just plot a few points, -1, 5, -2, 5. We see it's going to the left, and it's actually a horizontal line. And there's no end because it doesn't say to stop. It just says x is less than 0, so going to the left. All right, for my next one, I'm going to use 3x, xy. So this one tells me to start at 0 and stop at 3. So 0, 1, 2, and 3. Now 0 is less than or equal to, so that's a closed circle. And x is less than or equal to, so that's another closed circle. So for these, all we do is we plug these x values into x. So like 3 times 0 is 0, 3 times 1 is 3, 3 times 2 is 6, and 3 times 3 is 9. So I plot these points. So this is a closed circle at 0, 0. And then we go to 1, 3, 6, and then 9 is another closed circle. And we draw our graph. Then we have the last piece right here, x plus 2. So here's x and y. So it tells me to start at 3, and x is greater than 3. So values greater than 3 are 3, so 3 doesn't count, but 4, 5, and 6. So we're going to take these and plug them in. So 3 plus 2 is 5. 4 plus 2 is 6. 5 plus 2 is 7. So 5, 6, 7. This one has to be 8. And you can verify by checking it. So no equal bar, so that's an open circle. So we go to 3, 5, open circle, and then we go 4, 6, 5, 7, and we can see that it is going up like that. All right, now to check for discontinuous versus continuous, well, you can trace the graph, and if you can trace the graph without lifting your pen or pencil or your finger, then it is connected as one piece and it is continuous. So when I go through here, notice I have to lift my pen to go to the next piece, so therefore that is discontinuous. In terms of the domain, left to right, so furthest left is this arrowhead, which heads towards negative infinity. We see that it's connected, and it has an open circle right here. But if you look at this, this is a closed circle that would actually fill this in, and it's all the way up to here, so we have another closed circle. And the second piece has an open circle, but it's filled already because it's done. And this has an arrowhead that goes towards infinity. So hopefully you can see that this goes towards negative infinity and this goes towards positive infinity. So the domain is actually all real numbers. From the range, we go from the bottom to the top. So this arrowhead goes left in one direction, it does not go down, and this arrowhead goes up. So when I'm looking for my lowest point, I see that I have a closed circle right here at 0. Then I have an arrowhead that goes towards infinity. So this is 0 to infinity. And 0 is a closed circle, so that's a bracket, and infinity should always be in parentheses. All right, we can do the same thing for 35, 36. I'll do 35. So for number 35, we have this -3, xy. So it's telling me to start at -10 with an equal, so that's a closed circle, and go all the way to 0. And 0 is an open circle. And just like before, There is no number to plug into, so we know that all of these are -3. So I'm not going to graph them all, but I'm going to start at -10, -3, and put a closed circle. I'm going to go to 0, -3, and put an open circle. So I did put this in the wrong spot. So 1, 2, 3. And we're going to connect these, and once again, it is a horizontal line. So that's that constant function. For the next one, 2x minus 3, xy. So this one tells me to start at 0 and stop at 4. 0 has an equal bar, so that's closed. 4 also has an equal bar, so that's closed. So we plug them into here. So 2 times 0 minus 3. So 0 minus 3 is -3. 2 times 1 is 2, minus 3 is -1. 2 times 2 is 4, minus 3 is 1. 2 times 3 is 6, minus 3 is 3. 2 times 4 is 8, minus 3 is 5. So let's go ahead and start at 0, -3. And you notice there's an open circle that gets filled in by this point. 1, -1, 1, 1. Sorry, 2, 1, 3, 3, and 4, 5. And this one is also a closed circle. Okay, good. Make our dots connected. Then our last one is -x plus 9. So xy. So here it says x is greater than 4. So we start at 4. So bigger numbers, 5, 6, 7. So -4 plus 9 is 5. -5 plus 9 is 4. -6 plus 9 is 3. And hopefully you see this is going to be 2 when you work it out. Now, x is greater than 4, no equal bar, so there's going to be an open circle at 4, 5. But there's already closed, so we're going to just put the open circle. Then we're going to go to 5, 4, and 6, 3. 5, 4, 6, 3, 7, 2. So just like before, to do discontinuous versus continuous, we're going to trace it with our pen. And you'll notice that I do not have to lift my pen to get to the next piece. So this is a continuous function. Domain for this one, it starts right here at -10 with a closed circle. And it goes all the way to this arrowhead, which means it goes to infinity. So -10 with a bracket, because it's a closed circle, to infinity. For my range, now these do look like the lowest pieces, but this arrowhead means that it goes on forever. So this arrowhead actually goes towards a -infinity, and the highest point is this closed circle at 5. So least to greatest. Parentheses and closed circle is a bracket. All right, last we have this piece right here, number 36. So for 36 here, you see the equation, the absolute value of x minus 3, where x is less than 4, so the absolute value of x minus 3. So when I make my table, x is less than 4. So 4 less than 4 is 3, 2, 1, 0. So we take them, put them in. So 4 minus 3 is 1. The absolute value of 1 is 1. The absolute value of 3 minus 3 is 0, which is still 0. Then we have the absolute value of 2 minus 3. So 2 minus 3 is -1, but the absolute value is 1. 1 minus 3 is -2, but the absolute value of -2 is 2. And then 0 minus 3 is -3, but the absolute value is 3. So open circle for the first one. So right here, we're going to start at 4, 1. So 1, 2, 3, 4, and 1, open circle. Then we do 3, 0, 2, 1, 1, 2, 0, 3. And there we go. All right, for our next, it's only one other point. So it's at -1/4 of x plus 2. This one tells us to start at 4. And x is greater than or equal to 4. So 4, 5, 6, 7, and it's going to be a closed circle. Now, really quickly, one thing that does strike me is that this is 1/4. So I'm going to look for numbers that are divisible by 4. So like 4 is divisible by 1/4, right? So -1/4 of 4 plus 2. So -1/4 of 4 is -1. -1 plus 2 is 1. 5, 6, 7, 8, or 5, 6, and 7, you can do those using a calculator. I'm going to skip them. I'm going to go to 8. So -1/4 of 8 plus 2. So -1/4 of 8 is -2 plus 2, which is 0. So I'm going to plot these 2 points. So let's go to 4 and 1. That's going to be a closed circle, and notice we fill in that open one. And then we have 5, 6, 7, 8, 0, and there's my graph there. Okay, so in terms of continuous or discontinuous, you can trace the graph without lifting your pencil or pen. So this is going to be continuous. For the domain, this goes towards negative infinity, and this one goes towards positive infinity when you relate it to the x-axis. So negative infinity to positive infinity. For the range, this is heading down towards negative infinity, and this is heading up towards positive infinity. So negative infinity to positive infinity.